Welcome to the surgical theater. Grab your scalpel, because today we are dissecting Cambridge IGCSE Mathematics Syllabus 0580 with absolute precision. We're jumping straight into one of the most misunderstood topics on the paper, the hidden mathematical threads of direct and inverse variation. Now, I see two types of students in the exam room every single year. First, there's Alex. Alex overloads with raw mathematics facts, just dumping formulas onto the page without any real analysis of what the question actually requires. Then, there's Sam. Sam rushes, panics at the sight of complex data, and completely misses the command word requirements. Today, we are going to fix both of those flawed approaches. By the end of this strategy explainer, you're going to possess the precision instruments and steady hands needed to dissect these variation questions with surgical accuracy.
Here is our roadmap for today's session. We'll start with direct variation basics, move into proportions with powers, and then tackle inverse variation. After that, we'll master finding the constant, and finally, we'll apply all of this to real-world applications. And throughout all of this, we'll be applying our exam-winning strategies to make sure you're extracting maximum marks.
Section 1. Direct Variation Basics. Let's start with the absolute simplest thread. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, look at these two tables. In the first one, where y equals 2x, notice how as our x values go up, the y values go up predictably. 1 becomes 2, 2 becomes 4, and so on. The second table does the exact same thing, just at a steeper rate, where y equals 3x. If we graphed these tables, they'd both be perfectly straight lines passing directly through the origin. They move in perfect lockstep. Now, if Alex saw this on an exam, Alex would just copy the numbers down without explaining the relationship. If Sam saw this, Sam would rush, maybe miss the fact that it passes through 0, 0, and lose the mark. But we are going to look deeper and identify exactly what connects these variables.
This brings us to the core of our strategy. This predictability has a formal name, the constant of proportionality, or K. When the command word asks you to express y in terms of x, examiners are looking for you to use this specific framework. For direct variation, we translate the relationship into the equation y equals kx. That k is the exact same thing as the gradient of your straight-line graph. Now, this is where we introduce the Peel framework to mathematics. Peel stands for point, evidence, explanation, and link. Your point is stating the correct variation formula. Your evidence is substituting the data points from the table. Your explanation is algebraically solving for k, and your link is writing the final completed equation. K is the master key, and the Peel framework is how you prove to the examiner that you found it.
Section 2. Proportions with powers. Let's see what happens when the examiner turns up the heat. Let's move to our next section and see how this builds when the proportional patterns aren't just perfectly straight lines. This is a classic Cambridge trap. Look closely at this data. Sometimes y is directly proportional to a power, like x squared. As x goes from 1 to 5, our y values for the equation y equals 2x squared completely explode from 2 all the way up to 50. Sam usually loses 2 entire grade boundaries on questions like this because Sam rushes, assumes it's standard linear variation, and calculates the wrong constant. But with a steady hand, we can dissect this. If you were to plot x against y here, you wouldn't get a straight line. You'd get a severely curved graph. But the relationship is still strictly mathematically proportional.
This brilliantly illustrates the ultimate test, and it's a concept you absolutely must understand for paper 4. If you look at the left side, plotting y against standard x gives us that curve. That's messy. But on the right side, if you adapt your strategy, if you plot y against x squared instead of just x, the curve instantly straightens into a perfectly linear line passing right through the origin. This is your mathematical proof. This is how you show the examiner that you haven't just memorized facts like Alex, you actually understand the structural geometry of the question. You've proved the direct variation by manipulating the axes.
Section 3. Inverse variation. What happens when the variables fight against each other?
This brings us to inverse variation, where an increase in x leads to a proportional decrease in y. Think of it as sharing a limited resource. Mathematically, we write this as y is proportional to 1 over x, meaning the equation becomes y equals k divided by x. This is the surgical instrument you need for any question involving rates, speeds, or shared workloads. If you use the direct variation formula here, you get 0 marks, period. You must decode the language of the question first.
So, let's look at this challenge. If y equals 5 when x equals 3, how do we find y when x is 30 for an inverse relationship? Now, Alex would just try to cross-multiply here and completely butcher the logic. Sam would just guess. Let's initiate the transformation right now. How do we turn those red pen marks into green check marks? How do we structure an answer that forces the examiner to give us full marks? We need a universal blueprint.
Section 4. Finding the constant. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Welcome back to the surgical theater. This is the central heartbeat of our entire explainer, the universal method for finding our master key, K. No matter the problem, you always follow these exact 3 steps. This is the mathematics success blueprint. Step 1, write the proportional relationship. For this inverse problem, write y equals k over x. That's the point in our Peel framework. Step 2, substitute the known values. Plug in 5 for y and 3 for x. Multiply them out, and you find k equals 15. That's your evidence and explanation. Step 3, use the newly found formula to find the missing variable. Put 15 back in, divide by the new x, which is 30, and boom, y equals 0.5. That is your link back to the final question. By structuring your answer this way, you make it literally impossible for the examiner to deduct marks. You are showing them exactly what they want to see, step by step.
Section 5. Real-world applications. Time for our interactive workshop.
Now, let's take these tools out of the abstract and apply them to the highest stakes problems in the syllabus, the real physical world. These aren't just random letters on a page. Variation is the literal mathematical language that governs gravity, kinetic energy, geometry, and electricity. Look at this data scan. Falling stones where height is proportional to time squared. Moving bodies where velocity is proportional to the square root of kinetic energy. Expanding geometry linking length to the cube root of mass. Electrical circuits linking power to current squared. You have 60 seconds on an exam to extract the core trend from a word problem like this. Let's see how you do.
Here is your first interactive challenge. Let's look closely at this exact physics problem from the Cambridge source material. A stone takes 5 seconds to reach the ground when dropped off a cliff 125 meters high. The hidden trend here, which the command words usually hint at, is that height is proportional to the square of time. If you misread the command words and think it's just proportional to time, you've already lost. Always read the question twice, dissect the text, extract the variables.
Now for challenge 2, find the flaw. I want you to imagine Sam's paper right now. Sam sets up the equation h equals k times t. Sam substitutes 125 equals k times 5. Sam gets k equals 25. Where is the flaw? The flaw is that Sam rushed and forgot the square. Look at the correct calculation on screen. Step 1, equation is h equals k times t squared. Step 2, substitute 125 equals k times 5 squared. Step 3, simplify 125 equals k times 25. Do you see the difference precision makes? We didn't panic. We applied the Peel framework. We provided the evidence, and we explained the math by simplifying 5 squared to 25.
So, for our speed writing challenge, let's finish this off. In your head, divide 125 by 25. We discover that our constant of variation, k, equals exactly 5. This means we now have the universal formula, h equals 5t squared. With this single equation, we can calculate the height of any cliff just by timing the fall of a stone. You write that down clearly, double underline your final answer, and you've just secured full marks. Your mark potential for this question just hit 100%.
Let's lock this in with one final exam scenario. The power generated in an electrical circuit is proportional to the square of the current. When power is 108 watts, current is 6 amps. The exact same logical structure applies here. This is where you apply the time management matrix. This is a standard 3 to 4 mark question. You shouldn't spend more than 3 minutes on this. Don't overcomplicate it like Alex, don't rush it like Sam. Identify the command, proportional to the square. Set up P equals K times I squared.
By substituting 108 for power and 36 for current squared, because 6 times 6 is 36, we effortlessly reveal that the constant K for this circuit is 3. 108 divided by 36 is 3. Just like that, you've completely dismantled a complex physics-based math problem using basic arithmetic and a rock-solid strategy framework.
Let's pull everything together into our final system.
Finding the constant of variation k isn't just an exam trick, it's uncovering the hidden rules that keep the universe perfectly balanced. But more importantly for you, it's about following 3 golden rules that guarantee top marks. Rule 1. Command word decoding. Always identify if it's direct, inverse, squared, or rooted. Rule 2. PLL framework application. Structure your working out logically. Point, evidence, explanation, link. Rule 3. Time management matrix. Allocate your minutes based on the marks available. Execute these 3 rules, and your red marks will turn to green checks every single time.
The next time you look at a data table or a complex physics problem, ask yourself, what is K and how does it connect everything together? Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.